Hello and welcome to RCHacker. My name's Mark, and in this video today I'm going to do a teardown of the 130 amp high precision watt meter and power analyzer by Turnigy. I'm going to do this EEV blog style. If you've never seen his videos, Dave's videos, Google EEV blog. If you're into electronics, you'll enjoy his stuff. I've spent enough time watching his stuff. He's got 400 videos. Anyway, you know what he says? Don't turn it on, take it apart. Right. So we've got a manual here. Oh, it's in colour too. Yeah, cool. What are our specifications here? 4.8 to 60 volts. 0 volts with optional auxiliary battery. Okay, I get what that means. So apparently going down to 0 volts is not an easy thing to do, so this looks like it's pretty clever. 130 amps, resolution 0.01 amp, 0 to 60 volts, 0.01 volt, 6.5 kilowatts as well, so yeah, cool. And it measures amp hours and watt hours as well. It's got your standard LCD display, weighs 82 grams. Yeah, that tells you how to hook it up and all that sort of stuff, but that'll do for now. Alright, moving on. It's got, you notice it doesn't have any connectors on it, so if you're going to order one, get some connectors. Get your, I'd say most of the time you'd be using the XT60s. So, you know, you've got to have your own soldering iron and all that sort of stuff if you're going to get one of these. Before I take it apart, notice there's no buttons on it, no user interface, and there's a little 3-pin port there. I'd say that must be for the external power or maybe some sort of communications. Oh, there we go. It's got minus, plus, and it looks like a square wave symbol, so some sort of signal in there, same as the servo, so maybe it tests servos as well. Don't know. I'll find that out when I turn the thing on. Okay, so we'll whip the back of this off. Right out there. So I've got the LCD module is on one board. I'll probably assume that's just LCD there. All the circuitry on that is LCD, and then the actual board that does the business is that tiny board there. You can see there it's doing the sensing on the ground wires, and obviously, that's a bummer. The main chip is just a blob, so there's no way I'm going to tell what that is just by looking at it. There's a test point there, and there's 6 headers. That's probably an ISP port, in-system programming port there, labels for out plus and in plus. Okay, that one there, that little SOT is a Fairchild PNP high voltage amplifier. So yeah, I've got the data sheet just aside there, having a look at that. There's another tiny little transistor component there. You got the pins for the, I think that was the external power, I think. Presume it might be in the manual, but yeah, that's about it. There's not a lot to it. I don't know if we can see inside there. I wonder if I can light it up. There's just one more 8-pin SIOC on the bottom side of that board, and looks like a few more transistors and a couple of more passives. Not a lot, so we can't see what the main processor is on that. So obviously the main processor is in there. So there you go, not much more I can say about this. I'll put it together and give it a go. Do some measurements on my Mini Tricopter. So I'm back. I noticed something really interesting while I was doing the video editing. Over here you've got in minus and in plus, okay, and then over here as well you've got source SN, I presume that's source minus and source plus. Yeah, so source is for in and load there is for that SN. So I'm thinking that we can hook up smaller wires to this, so then rather than, if you want to measure small currents or something small that's not bloody over 5 amps or something, you can hook on a couple of extra smaller wires and save these big plugs for the big stuff, and then have a couple of tiny ones with alligator clips on it, which is really interesting. So I'm just going to get my multimeter and we'll test out if those pads correspond to the right ones here. It might be a bit tricky. I might have to trace the look at the circuit trace on there as well. Bear with me a sec. Alright, so in plus, no, there's no connection there at all. Oh, no, had it the wrong way. No, nothing. Yeah, I'm wondering what exactly is going on there. It's really hard to say without actually desoldering it up here and then having a look at the other side of the board. Maybe it'll automatically sense it if I hook something up and sense lower currents and lower voltages. If anyone knows of anything, like whether it does this or not, please let me know. But yeah, I thought that was really interesting, those extra pads there. It's obviously got more than one use. So I thought I may as well film soldering the plugs on. So I've got, you need a pretty beefy soldering iron for this job, which really, these things should come with the connectors on. It kind of limits it. I guess anyone who's going to measure this sort of stuff has probably got a soldering iron anyway, so I don't think they'd get that many complaints really. Really, it does take a lot of heating. I had to pull this plug out of that pack of 10 plugs I had. I've used them all up now, so I had to pull this off my one of my not so good tricopters that I built. This really is quite tricky, just to get it all hot enough. And this is where my clamping tools come in so handy. Oops. Need more flux. Now out here, the solder I get doesn't come with flux. I've got a big pot of the stuff, and it gets all bits of solder and there's bits of wire in it. But you know, this is my second pot of flux that I've used. Better than a flux pen, I reckon. I don't know, maybe the power station's on holiday or something, because there we go. Oh, I'm going to start squealing like a girl now. This is getting hot. The key is once you release and it starts cooling down. Yeah, not the best. Not the best job I've ever done. I'll add a bit more solder there. Make sure we got, like, if these leads have lead-free solder on them, actually, yeah, it just came undone like that. Well, it'll make it quite difficult to. You want to get rid of all that lead in that lead-free solder. It's also good to put your XT connector, plug it into another one before you solder these, because they tend to, they'll actually melt, and even though they say they're great quality, you can actually melt them. Alright, I think that one's good enough for my purposes. Make sure I've got on the right one. You got to look for the negative there on. Oh, focus. There we go. Look for the negative. Yeah, that's a pretty dodgy job. Anyway, so I'll try a different technique this time. Got plenty of flux on my solder. And let's give this a real good tinning. Like, really soak it so that lead mixes in with the lead-free stuff that's on these wires. Tap. A messy job. I've got this thin plywood on my bench here. It's actually a really nice old hardwood bench. This little office used to be a bar, actually. Right. I need some tweezers for this one. Plenty of flux on there to help conduct the heat. Now I'm not as tough as Bruce, so I'm not going to hold this with my hands. You don't want to put too much force on it either, because then you have too much force, you'll split the strands and the wire tend to come apart, and then once that dries you've got Buckley's chance of getting it all back together. So you just want to sit it there until it sits in there. That's a much nicer job. It doesn't have that nice. Still. Let's get focus. Not too bad. Now, look at this. Look what I forgot to do. I forgot to put the heat shrink on. Oh, bugger it. I'll just wrap it up in a bit of electrical tape. The good thing about this silicone stuff is you can really get it hot. Like it gets, it says 200 degrees C on the actual wire there, and I'm sure it's getting hotter than that, and it's not melting. Oops. yeah, like I said before, it's good to, whenever you're soldering these, have another connector plugged in, and that holds the terminals in place while they get really hot. Otherwise, any force and they can actually bend while you're trying to solder them. Right, so red is positive. Get a bit of solder on that first. It's also quite difficult when you got to put your arms around a camera and trying to film it at the same time. You know what? Well, let's do this properly. Well, I'm starting to run out of heat shrink. I don't know if it says what diameter that is. Oh, I can tell my eye. Yeah, there you go, it's 5mm. Yeah, about 5mm. That's the 5mm stuff. It's good for doing your connectors. I'll post this on my webpage, and I'll put a couple of links to the actual watt meter and the plugs and the heat shrink, so just so it's all in one place. If you want to buy the whole lot, you can click on my links. I'll get a small commission on the sale, and you know, Hobby King foots that bill, so helps me keep this blog going. Oh, I can't even hold on to that anymore. I showed you the heat shrink and then I forgot to put it on, didn't I? Idiot. Sorry, Tasha. I'm going to make sure it's cool enough before you can slot that heat shrink on. Oh, it's tight fit too. Yeah, that's like a perfect fit, that 5mm stuff. The black one's a bit bigger. There you go. And you want to put these well back, because this wire is going to get very hot and you don't want your heat shrink shrinking on you before you get a chance to put it on. These soldering irons, by the way, these gun ones, the design's been around since the 40s, I think. They're just a big transformer and a switch on your trigger. But you know, they do the business. That, you know, they're powerful and stuff. And if you want to, you can make custom tips with any sort of copper wire and stuff like that. If you've got other, and if you think of any sort of different uses. There we go. I don't know if I caught that on film, but when it dries, you'll see it'll just quickly go and change colour as it solidifies. I'll zoom this one in and see if I can get the other side. I don't want to melt my lens. The trouble is I'm going to have limited light. Now what's really annoying is this black wire is slightly longer than the red one, which makes it really difficult just to get in place. I'm going to have to use something a bit more. Crap, well sorry, I missed soldering that last piece on, but you get the idea. And you want to wait for that to well and truly cool before you put your heat shrink back on, and I've really made a mess of that, but it'll work. And even the plugs here and even the wires on the other side here are too hot to touch. Yeah, it does all get pretty hot. So yeah, all I'll do is slide that heat shrink down and over the joints, and I'm ready to test this out. Actually, I should also point out one of the reasons why this is probably so cheap is you saw how difficult that was to solder those on, and if you can imagine this on a production line, I don't know if they can do that sort of soldering on by robots. You know, there'd have to be some Chinese woman doing all that soldering, which will take a lot of time and would be very hard to get the quality. At least, you know, they can't be blamed for the quality of the soldering on those. Of course, if you did 1,000,000 of them, you'd get a hell of a lot better at it than what I am. I think that's cool enough to touch. So I'll slide our heat shrink back up, which has actually shrunk. I've got so much flux all over the place, it actually makes everything nice and slippery. There we go. I don't even need to heat that up, but yeah. It's not the neatest way, but I don't have a heat gun. What a wank. But yeah. Why use a heat gun when a simple lighter will suffice? So there we go. I hope I've got the plugs around the right way. Source goes to the male, I guess you call it. Well, depends how you look at it actually. Yeah, source goes to male, and then of course your battery. There's a battery I've got off the Tricopter. Yeah, so the battery fits in that end. And then this end clearly says load, so you have that end there on your load. And I'm done. I'm ready to test this out. Okay, so I got my Tricopter. I've bolted it to the table, and let's hook up our battery and see what happens. Now, can we see that? No. Okay, so idle, not doing anything with all my FPV gear on. We're drawing 650 milliamps and 7.1 watts. And the battery's at 10.93 volts. It's not a fully charged battery because I leave my batteries, I normally, if I'm not using my batteries, I put them on storage mode instead of fully charged or empty. That way they last longer. Alright, I'm going to try. I'm going to hold this down and we are armed. So that's a hover. In a hover we're at about 4.2 amps. And that was flat out. And something broke there. I don't know what it was. But I didn't catch that on. I didn't catch that. What was it? God, I smacked something. Anyway, let's try it again. I'll just clear it all out. I didn't realise this little thing spat out so much wind. Let's try that again and we'll see exactly how. I didn't hit anything. No. Must have whipped something up and whacked it. Alright, let's take two. I'm armed. That was about 20 amps, so there you go. My left motor here was actually losing power then. That's such a high current, so I've got some issues there with this motor up here. And that's my low battery warning kicking off on my with my FR Sky telemetry. So there you go. I got bugger. I got to look into this motor. I think I've just troubleshooted the issue that I had with this thing dying a lot, and I got to look back at my crash footage and figure out. Yes, I think that was the motor. So under full load, my little ESC can't handle it by the looks of it. Anyway. It's been RCHacker, and yeah, catch you next time. Cheers. Hey, I got it. How good was that? The Turnigy